What up, dogs? Mr. Allen here, solving some exponential equations in this video, and we're going to be using this cool thing called U-Substitution to do so. It's something that you're going to see more frequently in advanced mathematics moving forward, especially calculus. So let's bust it out right now, dogs. We've got two interesting equations here. I've got x's in two different, and we don't have like bases, and then I got a constant going on. What in the heck's happening here? I'm going to start with this one over here. I have 9 to the x plus 3 to the x equals 12. Well, let's try and get like bases first here. So 9 can be written as 3 squared, right? 3 squared, that's still to the x. This is still 3 to the x equals 12. Okay. Well, power to a power here, right? I would multiply those two. So I'd have 3 to the 2x plus 3 to the x equals 12. It's a tiny 12 that I have going on there. One more little switcheroo here. Could I rewrite this as 3 to the x squared and essentially flip-flop those two places there? I could, okay? Multiplication is, you can flip-flop a commutative, right? So I could rewrite it like that, and now I have 3 to the x. I'm going to subtract this 12 over because now I have essentially a quadratic in disguise. Check it out. It's not always easily noticeable right now, but I do have this 3 to the x and this 3 to the x here. What if I let u, as I talked about U-substitution, let u equal 3 to the x? And then if I rewrite this equation here as u squared, this is u squared, plus just 1u minus 12 equals 0, I can now factor this quadratic. What multiplies the negative 12 adds to positive 1. That's going to be u plus 4, u minus 3, and I can solve for u. So I get u equals negative 4 and u equals positive 3. Interesting. Is that what I wanted? No, it's not. I want to solve for x, but I use this U-substitution thing to help me solve this more complex problem. It's really hard to see what I need to do because I've got these exponents, 3 to the x, that's distracting from a quadratic standpoint. But now what I can do is I can throw the 3 to the x back in place of u. So 3 to the x equals negative 4, and 3 to the x equals 3. Well, question for you. 3 to some power. Can I ever get a negative answer for that? Well, if I use a positive exponent, it's just be a bigger number, unless it's between 0 and 1. If I use a negative exponent, it's just going to be a reciprocal. So if I did like 3 to the negative second, I just get 1 over 9. I don't get negative 9, I get 1 over 9. So this is actually impossible right here. I cannot solve this one, but 3 to what power gives me 3? 1. So x equals positive 1. Nice. Excellent non-calculator problem for a test or quiz or whatever, because all of this can be done without a calculator. I can't even solve this one. If it was 3 to the x equals 4, then I could use logs to solve it. But if it's not solvable, whether I have a calculator or not, that one is perfect non-calculator problem, okay? So be on the lookout for something like that on a non-calc advanced algebra 2 honors type test later on in the year, or perhaps a pre-calc honors test. Okay, or pre-calc regular, either one. Definitely fair game. This one now. So we're going to do the same kind of strategy here with the U-substitution, try to get like bases, raise the x to something, whatever, and then we'll do some of that fun stuff in quadratics and factoring. So now that you've had a look at this, perhaps you might want to pause it, try this one, and see if you can figure it out. But if not, I'm going to rock through it right now. 25 is the same as 5 squared raised to the x minus 4 times 5 to the x, and I'm actually going to rewrite it like this. That's the same thing, right? The x is only applied to the 5. That is totally cool to interchange. It's already equal to 0, which is nice. Now this one, remember that's the same as 5 to the 2x, which is then, I could actually just flip-flop where these two are, right? So this is 5. I could rewrite this as 5 to the x squared, because either way I'm going to get 5 to the 2x or 5 to the 2x. Either one's totally fine, okay? Minus 4 to the 5x plus 3. So the reason why I flip-flopped those and rewrote it, which we did show, but I'll show it again just in case, 5 to the 2x, and then I can rewrite this as 5 to the x squared. Cool? So this right here can become that, and then I can go to that, which is what I have right here. Whoop, whoop. Okay. I did that so that I can identify my u a little bit easier. That's u right there and there. So we'll say let u equal 5 to the x, and then we'll replace that in here. So we have u squared minus 4u plus 3 equals 0. And now I can factor and solve this bad boy. I've got u, let's see here, minus 3, u minus 1. That seem right? Negative 3 times negative 1 is positive 3. Add them up, get negative 4. Yeah. So then I have u equals 3 and u equals 1. So let's finish solving this. 5 to the x is equal to 3, right? 5 to the x is equal to 1. 5 to the x equals 3. 5 to the x equals 1. Well, this one here, to solve this, I would need to use logs. So I'm going to loop and swoop this bad boy, okay? You might not know what that is, but I'm going to show you right now. It's my little strategy from Mr. Thornley. Big dog, Mr. Thornley. Mr. T. Got to give him credit, okay, for the loop and swoop. It's going to be log base 5 of 3 equals x. And I can just type that into my calculator here. I would hit math alpha math. That's the green button right above math. It brings up the log any base. So base 5 of 3. And I get x is approximately 0.6826. So 0.683. If I round to the nearest thousandths, that's a th at the very end. 3 decimal places. Boom. Awesome. Okay. They could put this on a multiple choice non-calc, and that would be one of my answers there. They would just leave it in terms of a log. This is an exact answer. That's an approximate answer. It just depends on the test. But this one over here, another perfect scenario for a non-calc problem. 5 to what power gives me 1? Well, anything to this particular power gives me 1. It is 0. X equals 0 is my answer right here. Whether I have 12 to the 0 or 1,000,000 to the 0 or 7,562 to the 0, it's going to equal 1. There we go, guys. That was awesome. Thanks for mathing here. Exponential amounts of fun, if you will. U-Substitution, it's a new thing. Ain't going anywhere. Sometimes they use different variables for it, but I've pretty much mostly just seen U. I can't remember what other variable I've seen in the past, whether it's V or, I don't know, U-Substitution. No, I'm just kidding. U-Substitution is the common one. So hopefully that helps you guys. If you have any questions, pop them in the comments. Otherwise, thanks for watching and have an awesome day.